So hypothesis is a Greek word. What is the meaning of that? Hypo means tentative, and thesis means the solution. Yeah, solution for the problem. Okay, okay. It is a what is the statement of solution? Thesis is what statement of solution to the problem. So it is a tentative statement. So it is a very important for us. Okay. So how we start research? So we create some hypothesis, and once we create the hypothesis, what we need to do is we have to test the hypothesis. Okay. So now here we are seeing the hypothesis testing from the statistical point of view. In this case, there are two types of hypothesis. One is called as null hypothesis, and other hypotheses are called as alternative hypothesis. Okay. Null means what? There is no difference. Okay. So it is equal. Okay. But it depends. Okay. It depends. So we'll see that later on. Okay. So other than null hypothesis, the hypotheses are called as what? Alternative hypothesis. Okay. So here, now suppose we define three hypotheses, then one of the hypotheses will be correct, other hypothesis will not be correct. Okay. Only one at a time, one hypothesis at a time will be correct. Okay. Please understand, we have to create this hypothesis before going for sampling. Okay. Not like that we have tested the sample and then we create the hypothesis. That is a reverse way. It should not be there. Okay. Then it is not hypothesis. Hypothesis is what? Tentative statement. Okay. I'll move further. Now, suppose we want to go for hypothesis testing, then what we make? We make some criteria, like for particular population. Suppose the mean, we set the mean. Okay. Like I will give the one example that average height of the male Indian is suppose 5 feet 4 inch. Okay, so that will be our hypothesis mu h0. Okay. Then after we create this hypothesis, what we have to do is we have to select the sample, and then we find the mean. That will be your mu. Okay. Then we compare mu with the mu h0. But we have said that hypothesis that is called as null hypothesis, that for Indian male, the average height is 5 feet 4 inch. Okay. So that is our mu h0. Okay. Now we have to select sample. What is meant by sample? Like in India, there are almost what is population of India now? Almost 125 crores. Okay. So we cannot test all this. So we have to take the samples from different regions, and then we need to find the mu. Okay. So when our mu calculated from the sample and hypothesized mu, which is a guessed, okay, 5 feet 4 inch. If it matches, then what? Null hypothesis is true. If it is not true, means what? Alternative hypothesis is true. Okay, like this we have to go. Okay. When null hypothesis is not true, something else is true. That hypothesis are called as what? Alternative hypothesis. Okay. So I have given here, suppose we accept null hypothesis, means what? Alternative hypothesis are rejected. If we reject null hypothesis, means what? Alternative hypothesis are accepted.
Rejected.
Yeah. Yes. Now we'll see the what are the possibilities of alternative hypothesis. Okay, when I say the mu is equals to mu h0 means what? It is the null hypothesis. When mu is not equals to mu h0, that is one alternative, means population is not equals to 100, we can say. Second alternative is mu is greater than hypothesize mu, that is a mu h0, means population is greater than 100, and we can say mu is less than mu h0, means population is less than 100. So there are three alternatives possible for alternative hypothesis. Okay. Now, what is a guideline for selecting null hypothesis? So mostly what we want to prove is, as per guideline, they say that mostly we want to prove the alternative hypothesis, and we don't want to prove the null hypothesis. Okay. Then null hypothesis should be specific, it should not be approximate. Okay. So when so this is the third guideline that is very important. If rejection of certain hypothesis involves great risk, then what we have to do is we have to select that as a null hypothesis. Okay. And we have to reject, we have to minimize the probability of rejection by minimizing what is called as significance level, by selecting the low significance level. Okay. So in this way, we need to take care while selecting the null hypothesis. Now, we saw yesterday, I'm just repeating that because it is difficult topic. So level of significance, what is meant by level of significance? So it is a probability. Level of significance is what? Probability that even the H0, okay, H0 is correct, but it is rejected. That is rejection probability. Even when the null hypothesis is correct, that is called as level of significance. So we yesterday also saw that the level of significance will help you either way. We can reduce the error. That errors we will see later on now. So level of significance is very important, that we'll see now. Then
But
comes
sir, it should be higher. Sorry to intervene, but it should be high or low level of significance.
that I will discuss now. Okay.
Low, no?
Last time we saw that, but we will see both the way it is true. Okay.
Okay.
That we will see. Now, when it happens, like we have to decide the decision rule. Please understand. Now, suppose I have the sample, like I'm creating millions of the parts in my company, and that is called as what? Population. That is called as what? Population. From this population, I have to take the random sample. When I take the random sample, I have to decide the criteria when I have to pass the sample, when I have not to pass the sample. So how many defective pieces I permit in acceptable lot. Okay. So I decide that, and that is called a decision rule. Suppose I say, if I select the sample of 100, and in that there are the 2 defective pieces, then I will say the criteria for selection, criteria for accepting that if the faulty pieces are 2 or less than 2, then it is acceptable. That is a null hypothesis. If it is above that, it is rejected. Okay.
Rejected.
So this decision rule we have to decide. Okay.
Got it.
Before going for the sampling. Okay. Now next, Now when then we arrived at what is meant by type 1 error and type 2 error. What is the type 1 error? Type 1 error tells that what type 1 error is there? That H0 is correct. Okay, null hypothesis is correct. But what happens because of certain error, we reject that. It is true. Okay, null hypothesis is true, but we are rejecting. That is called as what? Type 1 error. Okay. Means it is correct. Means the, in other word, I will say that sample is acceptable. Okay. But what we do, we reject that. Okay. So that is called as type 1 error. Okay. So we reject the H0. Type 1 error means what?
How it is,
Yes.
sir?
Hello, your
We have
voice is.
selected one example for we have selected one example for this, no?
Mhm.
For two defective pieces in 100 sample it is accepted. Then what we can set for type 1 error if
Please
we found
understand,
two accept.
there is a probability. Okay, when I say
Okay.
I taken the sample of 100 pieces and I check the
Hmm.
all 100 pieces, but there is also the limitations of measurement. There is a limitation of manpower.
Time.
Okay, so what happens?
Hmm.
There are less than two or less than two defective pieces are there, but because of certain errors, we conclude that there are three pieces, four pieces. Okay.
Okay.
No, no,
Then this is type
no,
1
no.
error.
Yeah, yeah. This is a type 1 error. Which actually there are less than 2%, less than 2% are defective pieces, means it is actually what? The sample to be passed. But because of certain limitations, what we do, we declare that there are four defective pieces. Okay. In reality, it is acceptable, but we reject. Okay. So it is a type 1 error. Now we move to the type 2 error. In type 2 error, what happens? We accept H0, but it is in reality what? We accept H0, but it is not true. Okay. Means H0, suppose I said, give the same example here, that actually there are four faulty pieces, but we, after measurement, we say that there are only two faulty pieces. Means we accept that, but in reality, the sample is not acceptable. Are you getting? We accept H0, but it is not true. When H0 is not true, that is called as type 2 error. Okay. Means type 1 error, there is a rejection of hypothesis should have been accepted. Okay. So in type 1 error, it was expected that the sample will be accepted,
Yes.
but it is not accepted. Okay. So that is the type 1 error. Okay. So generally, type 1 error is denoted by the alpha, which is also called as level of significance. Okay. So directly level of significance is actually type 1 error. Okay. And type 2 error is called as beta. So there is no name to that. Now we'll see the in table. Okay. Yes. Any doubt? Okay. So we will see the table. I will just switch on the marker. On the left column, you can see that H0 is true. In reality, H0 is true. Okay. And there are now two options. If you accept H0, okay, it is true and we accept, means the number of faulty pieces are two or less than two, means it is acceptable in reality, and we also accept. So it becomes what? Correct decision. Okay. In reality, it is true, but we reject the H0, then it is called as what? Type 1 error. Also, we call it as the alpha error. Okay. Now, next is H0 is false, H0 is not correct. We accept that. If you accept that it is not correct, and we accept means what? It is type 2 error. We call it as a beta error. Next is H0 is false, and we reject H0 means what? It is a correct decision. So here it is showing the type 1 error and type 2 error. So what is happening? Error means what is happening. We are not saying when it is true. When it is true, we should accept this. When it is not true, we should reject this. When it is not happening, then whatever is happening, we call it as what? Error. We call it as a error because it can give some problem to your organization. So we'll just see one example from the chemical point of view. Okay. So what happens to this when it comes to the chemicals? Okay, just go to this. Now, before that, I will give that one example from chemicals which are to be consumed, like medicine chemicals. Now, when we see the relation between the type 1 error and type 2 error, they are related. What is happening to them? Type 1 error and type 2 error, both are related to each other. And when we increase type 1 error, what happens to type 2 error? Decreases. If we increase the type 2 error, what happens to the type 1 error? It decreases. So there is inverse relation, we can say, between the type 1 and type 2 error.
Type 2.
So both the errors we cannot reduce. Both the errors we cannot reduce at the same time. Okay, so we have to take the decision how much level of type 1 error we need to permit and how much level of type 2 error we need to permit. Okay, so we have to take the balance between these two errors. So I will give example where now basically what we want is we want type 1 error to be less, because what happening in a type 1 error, please understand here, in type 1 error, the lot is when it is lot is, we can say, acceptable, but because of something, some conditions, some measurements, we are rejecting that. Okay, here what is happening to our company, that we are losing, what we are doing, we are losing some our business. Okay, business in the sense we are rejecting the thing which is acceptable. Okay, so we are losing our sale because we have invested on the components, chemicals. So it is obvious that we want to reduce the type 1 error to reduce the losses. Okay, but I will give one example here, that where you are forced to make type 1 error less, we can say type 1 error to increase to reduce the type 2 error. So it is about the chemical. We know that some chemicals are used for medicine purpose. Okay, so I have taken one example from here, medical chemical. Suppose we are dealing with a chemical. If the type 1 error occurs, so type 1 error occurs means what happened? So in reality, that chemical is acceptable, but we reject that. Okay, when we reject that, what will happen? There is a loss to the company. Okay, so suppose accidentally we come to know that whatever was correct sample and we rejected that, we can again recheck that and decide that, okay, whether it was correct sample, we can say true sample, and it was rejected. So it takes time. Okay, so this will not create any harm to the human being, because what is happening, the right chemical was rejected. Okay, so it is not harm to the any person. Okay, now what happens to the type 2 error? Type 2 error, what happens? The chemical which should not be accepted is accepted. Okay, type 2 error, what happens? The chemical which should not be accepted is accepted. Okay, so it will create very huge problem to the human beings. So suppose such chemical goes in the market and suppose it is creating any harm to the human being. So legally, the company will be in trouble as well as it will lose its market share, because if the people come to know that this company, the care is not taken, so obviously they will lose the name as well as business. Okay, so in such case, so even though our interest is in profit, where we should reduce the type 1 error and can permit the type 2 error, but here it is coming to the risk of the human health. So in this case, what we have to do is we have to increase the type 1 error, even though for us it is a loss, rework we can say, and reduce the type 2 error. Please understand here, yes. Is there any question? So here we have taken one case where even though type 1 error increase means what? It is a loss to the company, but you have to do for the sake of human health, that we have to increase the type 1 error and reduce the type 2 error. Okay. Now I'll just go back. So as I mentioned, type 1 error, type 2 error, they are linked. And if you increase one error, other error, if you increase one, if you reduce one error, other error increases. Okay, so we have to very judiciously decide the level of type 1 error and type 2 error by examining the costs and penalties. I have already given the example by comparing the cost, penalties, cost and penalties which are linked to that errors, and what is the effect on our company by selecting such errors. So I've just given one important example on chemical testing. So in chemical case, we have to sufficiently increase the type 1 error to reduce the type 2 error. Okay. So we need to take this decision based on the situations. Now we come to our next step. Now, as I mentioned, alternative hypothesis, either it can be two-tailed or one-tailed test. Okay. When I say particular mu H0 is having some particular value, okay, if it is not achieved, then that is called as what? Alternative hypothesis. So whether alternative hypothesis is two-tailed or one-tailed test, that we'll see here. So we'll see here two-tailed test. When a sample is significantly higher or lower than hypothesized value of the mean of the population, then such is called as two-tailed test. Okay, so we'll give certain value. Okay, if it is below or above that, then it is the what is called that particular hypothesis. Okay, if it is inside that, then it is acceptable. It is, if it is beyond that, it is the rejected. Okay, so test is appropriate when null hypothesis is some specified value. So we specify certain value for null hypothesis, and alternative hypothesis is what? Value not equal to specified value of the null hypothesis, means it is either greater or lower. That is called as two-tailed condition. I will also show with the diagram. Now we'll see with the mathematical statement, two-tailed test. So, as I mentioned, that for null hypothesis, your mean of population, when it is equals to hypothesized population, then it will be a null hypothesis. We can say acceptable, but if it is not, then it is the alternative hypothesis. So mu is not equals to mu 0, but we say that here that when mu is either greater than mu h0 or mu is either less than mu h0. Okay, so it is both the ends. You can see in the diagram. Mu is less than mu h0, or, and we can say here and. Okay, mu is greater than or less than mu h0. Okay, either it is greater or it is less than mu h0. So here we can, in short, we can say that there are two rejections regions, one on each tail. Okay, one on each tail. Okay, so when we see the standard distribution curve, so end, it is having the ends. Okay, that ends are called as tails. So we can say the alternative hypothesis is on the both the tails. Alternative hypothesis is on the both the tails. That I will show in the diagram. When the null hypothesis is some specified value and alternative hypothesis is not equal to the specified value of null hypothesis. So here the null hypothesis will be the mu h0. When mu is equals to mu h0, it is the null hypothesis. In other case, if it is not true, if mu is greater than mu h0, this can be your alternative hypothesis, or mu is less than mu h0 will be your alternative hypothesis. Okay, so we will move and see the diagram. So I am showing you this diagram of standard distribution. Okay, so we take certain alpha. Here I have taken the alpha. Alpha is significance level. What is the significance level that I will describe again? It is the probability, maximum probability that it is a maximum probability that even the h0 is true, it is rejected. What is that? Alpha is the probability that even h0 is true, it is rejected. Okay, so it is
level of significance.
Level of significance, alpha. Okay, when I say 5% chances of rejection, means how much percentage is possibility? 95% is possibility. So I will mark this area for what is called as H0. How much it will be area? 95%. 95% is what? Point and 95. Okay. So if you see this standard distribution curve, we have to find first center of this midpoint, and 40. What is the half of 95%? 47.5% on this side, 47.5 on this side. Okay. So I will say what is the probability distribution on this standard curve? It is this much region. Okay. What is that? This is the acceptable region. Okay. So what is its probability? Probability is 95%. So on this dome, so maximum at the base, we can say here here up to it is what? Half of 95% is 47.5% this side
47.
and 47.5% this side. Okay. Now remaining of this dome, so that is the 5%. So we have to again divide 5% here. It will be 0.025 means 2.5% this side and 2.5% this side. So for standard distribution, there is value of Z. Okay. So what is this? So from the center, what is the level of this Z? So we will see this. What is the Z there when we go to statistics? Okay. So value of Z here comes minus 1.96, and this side it will be plus 1.96. So from here we have to see there is table is available for this. From that we have to see. Now in the this is the acceptable range probability, and this is the rejection range. Okay, this is the rejection range. Okay, so this curve. Now how to find the value of Z? So there is a table for standard. This is table. You can see this standard curve, standard normal curve. So how we find this Z? So now for us, our case, it is how much was percentage? 47.5% of error. Okay, 40.475. So here you go 0.475 where it is coming. So I'll just mark start the marker 0.475. It is coming here.
So how do
Yeah. So you have to select that
what is
area
this?
47.5. Correct.
Okay.
So here it is 1.9. And what is this? It is 0.06. So we have to write 1.9 and this 0.06 we have to add. So it will come 1.96. Okay, so that's why I will just clear 1.96. You will see now we have selected from this chart. So that is we have used here. Okay, we have used 1.96 here. That
Calculating theoretical. Sorry. This is
so
statistical.
Z value, yeah, it is statistical curve actually, normal distribution. So what is the value of Z? So we have to use Z in some equations. Okay, so that is coming to be 1.96. This is two-tailed curve. Similarly, we have to find for single-tailed curve. Okay. So this value of Z we have to take from this chart. Now in the single tail test, like here in two-tail test, there were two alternatives. One is either a mu is greater than mu 0. Second alternative was either mu was less than mu h 0. Okay, two alternatives. So I will say I will show you the tail first. Okay, so I forgot to send that show you tail. So the end of this curve, these are the tail. Okay. So here there are two tails where there will be rejection. This tail one rejection, this tail one rejection. So it is called as two tail rejection. Now I'll go for next case where it will be single tail. Okay. So I think time is over. After break we'll take. Okay. Thank you.
Okay.